So what we just showed in the last video is that an economically optimal insurance contract should just be that you pay the insurance company a fixed amount of money every month or every year, and then they cover 100% of the costs if something bad happens to you, right? So homeowners insurance, you should get 100% compensation for a new house if your house burns down by paying a particular premium every year, right? Health insurance, you should be able to get 100% of your health care covered by your insurance company once you pay them your premium. Same thing for car insurance, right? But as some of you might be thinking right now, this doesn't sound very much like what insurance looks like in the real world. Real world insurance is both a lot more complicated than this and also a lot worse than this, right? A lot worse for consumers. So if you have health insurance, it's likely that in addition to having to pay a premium every year or every month, you're also going to have to pay a deductible, meaning that your insurance only kicks in once you've spent a certain amount of money over the course of the year. You might also have to pay something like a copay, right? Every time you go to see the doctor, you might have to chip in 20 bucks or 10 bucks, something like this, and have the insurance company only cover the remainder. And for that matter, you might also have things like co-insurance, where the insurance company covers, say, 70% of whatever the covered medical expenses are, but you have to cover the other 30%, right? This is equivalent in our house example of saying if your house burns down, the insurance company will give you maybe $600,000, the other $200,000 are your problem. So, and on top of the fact that we've got all of these extra expenses and costs, right, much more complicated contracts than the ones we laid out, insurance companies in the real world also do things that don't seem that connected to sharing risk at all. So, for example, I had car insurance for a while that gave a discount if I downloaded an app that tracked my driving, right? So they wanted to see how fast do I accelerate? Do I stop at all the stop signs, right? Do I speed on the highway? And gave me discounts for good driving, right? So this is this sort of very intrusive, invasive behavior, right? It's not that connected to sharing risks with me. Likewise with health insurance. You might get an HMO that says, we'll only cover your healthcare expenditures if a doctor on our approved list has seen you and said that you need the healthcare that you're provided with, right? And you need to get that healthcare from another doctor on our approved list. And likewise, you might get incentives for things like eating well or exercising from your healthcare company. So why is it that real world insurance is so much more complicated and so much worse than this idealized insurance that we said ought to come out as a result of risk sharing? Well, there's effectively two problems that mess up insurance markets, right? There's two problems that are faced by consumers or firms that want to deal in insurance. So the first problem is information asymmetry. Which is essentially saying, the problem is that I might know more about my risks, my health risks, my risk of having my house burned down, et cetera, than the insurance company does. And the second problem is what I'm going to call moral hazard. And that essentially means that the actual risks of me needing medical attention or having my house burned down might be influenced by getting insurance. And both of these are going to push insurance companies against fully insuring individuals. In other words, against giving you a contract that says, if something bad happens, we'll take 100% responsibility of it. So we're going to spend a lot of time talking about information asymmetry, a little bit of time talking about moral hazard. In general, right, information asymmetry refers to a situation where one person in the market has pertinent information that the other person doesn't have. So before we dive into how this looks in insurance markets, let's go back to a simpler market. The example we gave in the welfare theorems lecture, where we're thinking about buying and selling used cars, right? So let's say that there's two kinds of used cars. There's good cars and there's bad cars, right? Just to keep things relatively simple. And let's say that for buyers, right, a good car is worth $1,000. A bad car is worth $500. And for sellers, right, they're willing to give up a good car for any price above $800. They're willing to give up a bad car for any price above $450. Right? if everyone knew whether the car is good or bad, there's no problem at all, right? We can have a sale price anywhere from, if everyone knew whether the car is good or bad, right, we could have a sale price anywhere between 1,000 and 800, say 900, right? If everyone knew that the car is bad, we could have a sale price of, say, 475, right? And if no one knew whether the car is good or bad, right, let's say half cars are good, half cars are bad, and we don't know what's going to happen, right, whether a particular car is good or bad, then as a buyer, right, I'm going to be willing to pay 50% times 1,000 plus 50% times 500 is 750. Right, as a seller, I'm going to be willing to accept a price that's 50% times 800 plus 50% times 450. Right, so that's going to be 400 plus 225 is 625. Right, so we could have any sort of sale price in between these two numbers. Now, the problem is, let's just say 700. The problem comes in when sellers know whether the car they're selling is good, but buyers don't know, right? The reason that this becomes a problem is, if I know that I have a good car, I'm not going to be willing to sell it at a price of $700, right? My minimum price if I've got a good car is $800. So, if a buyer thought there was a 50-50 chance that their car is going to be good, they're going to offer a price that only sellers of bad cars are going to accept, right? Bad car sellers are very happy to take $700 for their car. And as a result of that, right, the likelihood of getting a good car by offering $700 isn't 50%, it's actually 0%, right? So what we end up with in equilibrium is that nobody ever buys or sells good cars. The only market that exists is going to be for bad cars, right? And the reason is, if you have a good car, there's no way for you to show the buyer that they ought to offer you a higher price for your car, right? So this is the basic information asymmetry problem, right? If I can't verify the information that someone's giving me, if I know that they have information I lack, I'm going to end up making assumptions under a lot of circumstances that essentially the worst possible outcome is the only outcome that's going to happen, right? So let's think about how this applies to the insurance market. If we think about our homeowners insurance market that we talked about before, right, we said that on average, people have a 1% chance of having their house burned down in Highland Park. But let's imagine that the likelihood that any particular person's house burns down is going to depend on what type of person they are. Right, in particular, let's imagine that we've got high-risk people and we've got low-risk people. Right, so you might be high risk. You're very fond of frying a turkey on your deck on Thanksgiving, and let the oil boil over and catch fire. Watch those YouTube videos; they're fun. Right, you're setting off fireworks every time the Dodgers score a run. You like to leave your oven burners on just in case you're going to use them, and store your paper towels right on top of your stove. Right, as a result of all these sorts of behaviors, you've got, let's say, a probability of a fire of 5%, right? On the other hand, you've got people who are low risk, right? Their idea of cooking is using a blender or making cold oats, right? They use electric candles. They hate the smell of incense. They prefer it to be cold in their apartments in the winter. So there's really very, very low risk that they're ever going to set a fire, right? Let's say that their probability of a fire is 0.001, right? So they've got a 1 in 1,000 chance of having their house catch on fire. If we have 4 times as many low-risk people as high-risk people, we're going to get an average probability of having a fire of about 1%, right? Just like we had before. So, if everyone bought insurance, right, at the premium that we said before, right, the $10,000 premium, we're going to be totally fine, right? We're going to say that we'll have exactly the same market we had before. But let's think about whether it's worth it if you're low risk to buy insurance, right? So your utility with no insurance, right? Your expected utility with no insurance is going to be 0.999 times 810,000 to the 1/2, right, plus 0.001 times 10,000 to the 1/2. Right, so this is going to be 0.999 times 900 plus 0.001 times 100, right? So this is going to be, what's 0.1% of 900? It's going to be 0.9. So this is going to be 899.1 plus 0.1, which is going to be 899.2. And our certainty equivalent, right, 899.2 squared is going to be 808,500. Right? So what this means is, I'm as happy with accepting the risk that my house might burn down 1 year out of every 1,000. Right? I'm as happy here as if I had $808,000, $808,500 with no risk at all of a fire. So the maximum premium I'll pay would be 810 minus 808, right, which is going to be $1,500. Right, so I'm not going to be willing to pay $10,000 because I know that I don't have a high enough risk to justify this. On the other hand, let's think about the high risk people. Right, so if they had no insurance, right, their expected utility is going to be 0.95 times 810,000 plus 0.05, 810,000 to 1/2, 0.05 times 10,000 to the 1/2. Right? So this is going to be 0.95 times 900 plus 0.05 times 100, which is going to be 860. Right? 855 plus 5 is 860. So then 860 squared, right, their certainty equivalent, is going to be about $739,000. So their max premium is going to be, right, 810 minus 739 is going to be about $70,000, $71,000. Right? So since they know that they're at a very, very high risk of having their house burned down, they're going to be running to the insurance office, right, to buy full home insurance for $10,000. So what this means is, if I'm an insurance company and I offer these two populations of people the same plan, right, a plan that would make me money on average, I'm going to end up losing my shirt because all of the high-risk people are going to buy my plan. All of the low-risk people are going to say, you know what, it's not worth it, right? I'm going to take myself out of the market. This wouldn't be a problem if I know, as an insurance company, whether you're the kind of person who uses a turkey fryer or the kind of person who makes cold oats, right? But it is going to be a problem if I can't tell the difference between these two kinds of people, right? If there's no information asymmetry, right? Because then I can't offer a low premium to the low-risk group and a high premium to the high-risk group in order to tell these two groups of people apart. So what this might explain, right, what we might expect here is basically the same thing we saw in the used car market, right? We're going to end up with insurance premiums that are designed only for the highest risk people and have all the low-risk people go totally unprotected. So how would health insurance companies deal with this? Right? How can they avoid having the market degenerate until only the highest risk people are buying insurance? Well, there's really two strategies. So the first strategy is screening, right? Which is to say, effectively, insurance companies can do work to learn who's low risk and who's high risk. So this is, for example, what my car insurance company was doing by having me download an app that recorded how fast I drove, how much I accelerated, et cetera, et cetera, et cetera. This is what health insurance companies do if they make you come in for a health screening, or if they charge different rates based on whether you have pre-existing conditions or comorbidities. And if you do this, right, essentially what you do is you offer a better deal to those who you deem lower risk. The second option, if you can't screen or you don't want to screen, is to offer incentive-compatible deals. What do I mean by incentive-compatible deals? Essentially, I mean that you're going to make a plan designed to be unattractive to high-risk individuals. As a result, the only people who will choose to buy the plan are going to be those with low risks, right? So in the home insurance example, right, you want to design a plan that nobody who thinks they're likely to have a fire would decide to buy. As a result, right, you're going to be able to profit off of the low probability that those who choose your plan actually have a fire. So how do we do that? What does it look like to design a plan that's incentive compatible in this context? Well, the difference between high risk and low risk people is that low risk people care a little bit less about what they get if their house burns down in a fire because of the fact that that's less likely to happen. Right? So how do you offer an incentive compatible deal? Right? You cover less than the full amount of damage. So for example, let's say that the insurance company decided that they were only going to cover $200,000 of damage if there's a fire. Right? So instead of covering the whole $800,000, they're only going to cover the first $200,000. So you're still going to be in pretty bad shape if your house burns down in a fire. However, because you're offering so little money, your payment, right, your annual premium is only going to be $200 a year. So if the insurance company offers this bad plan at the same time that they offer a full insurance, right, where they pay $800,000 if your house burns down with a premium of, let's say, $40,000 a year, their goal would be to design this plan so that plan A is only going to be selected by the low risk types. So does this work? Well, if you're the high risk type, your expected utility in plan A is going to be, right, 0.95 times your outcome if you don't have a fire, right, which is going to be 899,000, oh gosh, I'm sorry, 809,800, right, plus 0.05 times your outcome if you do have a fire, which is going to be that you get 210,000, right? This is going to end up being 877.1. On the other hand, your expected utility for plan B, right, is going to be, well, in plan B, regardless of whether there's a fire or not, you paid $40,000 out of your 810, so you're going to end up with $770,000, right? So your expected utility there is going to be 877.5. So if you're a risky type, you're going to be better off with plan B than you would be with plan A, right? Your utility is higher, paying a lot of money for full insurance than paying just a little bit of money for partial insurance. On the other hand, right, if you're low risk, then your expected utility of plan A is going to be 0.999 times 809,800, the 1/2, plus 0.001 times 210,000, the 1/2, which is going to end up being 899.3. Your expected utility from B is going to be exactly the same as the high-risk persons, right? Since you're fully insured, it's going to be 877.5. So if you're low risk, you're going to prefer the bad insurance plan, right? The less extensive insurance. So what does this mean? It means that by designing a plan that intentionally underinsures people, right, insurance companies are able to offer a plan to low-risk types and to high-risk types without knowing what type each individual is. So on the one hand, this is a good thing to be able to do, right, because it's preferable to only being able to offer a high-cost insurance plan that low-risk types aren't going to take at all, right? This is better than them getting no insurance at all. But it's important to note, this low-cost plan is really, really bad insurance, right? If your house burns down, you only get a quarter of that value back. You're still living life on the edge. For people who have the bad thing happen, this is really not a good situation at all. And so the important thing to take away from this, right, is that when we have these information asymmetries, right, when the buyer and the seller don't agree on what the insurance product is they're selling, in particular, how likely it is to pay out, we can end up pretty far from the economically optimal outcome, right, which would be these low-risk types paying something below $1,500 a year and getting fully insured.